My name is Chase Gibson. I'm a technical sales specialist with Mori Microwave, and today I'll be demonstrating how Insight can be useful for prolonging the usable life of older VNAs. The 8510, for instance, is one of the first commercial VNAs which was incredibly successful. It is to our understanding that HP sold thousands of these units before its discontinuation in the early 2000s. Being 35 plus years old, these units may show age such as damaged or non-functional hard keys, obsolete cartridges and diskettes to load cal kits, dead or damaged displays, lack of a modern interface which can be kind of clunky to use, a lack of compatibility with modern calibration techniques, and finally, lacks the paradigm of uncertainty. Ultimately, it'd be a shame to stop using such an incredible instrument because of cosmetic deficiencies or outdated software. Well, Mori has a solution to extend the life of the 8510 and make it a desirable instrument in your test lab. And all of this at a fraction of the cost of replacing this perfectly good instrument. Introducing Insight, the industry's first commercial software suite designed to empower VNA users by revolutionizing the calibration, validation, measurement, and analysis process. In addition, takes into account measurement uncertainties and extends the life of outdated VNAs.
Let's start off by taking a look at HP's 8510 VNA. This unit that I have here was in the warehouse and has broken touch keys, which will give you a headache while navigating the different menus. For those of you who are seeing the 8510 for the first time, you can see that there are a lot of buttons and menus to navigate through, from setting the source in the local menu to setting the power level and frequency range in the stimulus menu. The list doesn't stop there either. You still have the S parameter, format, and response menus to go through to make sure that all of your settings are dialed in properly. And don't forget, with having broken touch keys, this would make dialing in your calibration settings even more difficult. You may be already thinking to yourself that this can be a tedious process to go through every time you calibrate your VNA. Well, let's jump right into Insight to show you how much more friendly this process can be. When you first open Insight, there are three modules that you can choose from. First is the configuration and settings module, preceding that is the calibrate, validate, and measure module, and lastly there's the plot module. Let's first take a look at the configuration and settings module. I'll go ahead and start things off by selecting the Keysight 8510 VNA model from our extensive list. You will notice that we have support for most commercial VNAs, including other discontinued and obsoleted models, which may also suffer from similar problems like my 8510. As an added benefit, not only will Insight take over the front end from the VNA, but I can also use it to characterize noise and drift, adding the VNA's uncertainties to the total budget, but more on that later. Since I've characterized a specific unit ahead of time, I'll just load that file now. Once things are taken care of the VNA, let's move on to the CalKit tab. In this tab, I can manage multiple VNA cal kits and types, including polynomial and characterized kits. Insight helps to take over the responsibilities of setting the cal kit definitions, storing that information in a centralized database, and makes all cal kits and cal types compatible with all VNAs, even if not originally supported by the VNA, like my 8510. You will notice three more tabs: cables, connectors, and probes. These are optional tabs to characterize the uncertainty contribution of flexing your specific cable, as well as connector and probe repeatability. When characterized and applied to the measurement, not only will you get S parameters, but you will get S parameters with uncertainty. We'll explore that more in a different video. Now that all the tabs inside the configuration and settings module are covered, let's move on to the calibrate, validate, and measure module. First, let's take a look at the Profile Setup tab, where the user can either create a new calibration profile, load an existing profile, or load an existing calibration. This can be very helpful to replicate identical setups regardless of the person driving the software. You can also choose whether to include uncertainties and if your measurements will be coaxial or on wafer. After completing the profile setup, I'll move on to the VNA Selection tab. Here, I'll go ahead and choose the 8510 previously configured in the last module. You can then designate the ports wanted to be used, as well as set the averaging, port power levels, and IF bandwidth. I'll then set the frequency settings such as start and stop points, step size, and number of points all in one interface, unlike the front panel process of the 8510. Once the frequency range is fully set up, I can then select the CalKit and method of calibration. For the CalKit, either choosing between a polynomial CalKit or characterized CalKit with uncertainty. As for the calibration methods, the list is also quite extensive and ranges from SOLT, TRL, LRM, and you can even perform on-wafer calibrations. In my case, I chose to go with the one-port SOL calibration method using the characterized CalKit, which will also empower measuring S parameters with uncertainty. Once my calibration method is set, I can proceed on to setting up the cable and connector uncertainties in the next tab. I'll go ahead and load the uncertainty files created from the previous module to add to the total uncertainty budget. Remember, this is an optional step, but it does add a lot of insight into your measurements and can help increase your confidence in taking those measurements. And that's it as far as dialing in your calibration settings. Now, the software will prompt the user to go through the calibration measurement process of connecting the standards. For the sake of time, I'll fast forward to the end of the calibration step. At this point, I now have the option to validate or start taking measurements, but of course it is always recommended to validate your calibration and check if it meets the desired level of accuracy before making a measurement. That way, you can be more confident about the validity of your data. In the Validation tab, you have the option to choose between Mori's verification kit or the commonly used method of source match. For this video, I'll just be covering the verification kit briefly. Under this section, I can verify my calibration either using a 1 or 2 port verification standard, choosing between the load or short for the 1 port verification to the match or mismatch beaded airlines for the 2 port verification. I ended up choosing to go with the 1 port verification load. I then measured and fetched the definition file of the load standard so that the data can be computed to show the measurement error in my calibration. This is where the benefit of having a characterized cal kit comes into play. The uncertainties included with the kit helps you decide if you need to calibrate again. This can now enable your 8510 to have a pass-fail criteria to enable the user to know how accurate their calibration is. Now that I'm done validating my calibration and have an idea of how accurate it is, I can move on to confidently taking measurements. In the Measurements tab, I can select from a list of quick plots, set the sweep mode, and configure the averaging and port power of the measurement. There is also an uncertainty section that can display the total uncertainty budget and the individual contributions from the equipment, which I will cover more in depth in the plot module. And lastly, there is the Analyze section, which allows the user to de-embed, normalize traces, unwrap phase, and more. Before I move on to the plot module, I'll quickly obtain some data of a 24-inch Mori Stability Plus cable connected over to a short standard. Let's jump right into the plot module next. This module is used when multiple files want to be plotted and is a standalone software that lets you plot S1P, S2P, and SDATB measurement files. You can perform the same actions as the Measurement tab, but now you can also create your own plots from scratch, select one of our predefined plots, or load in a previous session with data files. If you want to get extra creative, there is even a section to assign specific colors to the traces to help differentiate between the data more easily. I'll next enable the total uncertainties to be displayed. In the budget pop-up window, it displays the individual uncertainty contributions coming from the equipment that was characterized. The uncertainty budget can help pinpoint the source of inaccuracy in your calibration so that you know exactly what to change about your setup to improve your system performance. For example, if the cable is a source of max uncertainty, you now know what to replace rather than having to troubleshoot other components in the system, which can be a huge addition to the capabilities of the 8510.
To wrap things up, don't let that perfectly good VNA go to waste. Using Insight, you can breathe a second life into any older VNA make or model, including but not limited to HP's older 8510s, 8720s, and 8753 models, as well as Rohde & Schwarz's ZVRs and ZVCs, and even the Wiltron 360. We support them all. For more information or to download your own demonstration copy of Insight, please visit morimw.com. Thanks for tuning in.